Permutation and combination. Last time I ended with permutation, so I already spoke about permutation and I ended my last lecture with the permutation formula and how you can use the permutation formula to find the number of ordered arrangement of objects from a set. So this is our permutation formula. You read this as n permutation k. It is equal to n factorial divided by n minus k factorial, where n factorial is equal to n times n minus 1 times n minus 2, so on and so forth until you get to 2 times 1, or that is the same as this. N factorial is equal to 1 times 2 times 3 times ... times n. These are the other notations for permutation. I forgot to mention this. N here is a non-negative integer. When n is equal to 0, 0 factorial is equal to 1. Permutation refers to the number of ways the elements of a set can be ordered or arranged. So for example, we have this set A, or a set that contains A, B, and C. The permutations of these elements are ABC, ACB, CAB, BAC, BCA, and CBA. So we have 6. 1, 2, 3, 4, 5, and 6. So these are the permutations, and the number of permutations is 6. We can arrive at 6 in 2 ways. Using the permutation formula, of course, or using your fundamental counting principle. In the first experiment, which is to choose what letter to write in the first slot, we have 3 possible choices. So n sub 1 is equal to 3. For the second slot, we are left with only 2 choices. And for the third slot, we are left with only 1 choice. And so using your fundamental counting principle, the total number of outcomes would be 3 times 2 times 1, which is equal to 6. We shall arrive at the same answer using your permutation formula. So 3 permutation 3, n factorial divided by n minus k factorial. 3 factorial is equal to 6. 3 minus 3 factorial is equal to 0 factorial, and that is equal to 1. And so it's equal to 6 divided by 1, which is equal to 6. Given a set S with elements A, B, and C, how many permutations of objects will arise if you choose only 2 objects from set S? We can obtain the number of permutations in 2 ways. First, using your fundamental counting principle, which is equal to 3 times 2. Again, n sub 1 is equal to 3. For the first slot, we have 3 choices. For the second slot, we are left with only 2 choices. And so, it's going to be 3 times 2. The total number of outcomes is equal to 6. So, these are the permutations. AB, BA, AC, CA, BC, and CB. 1, 2, 3, 4, 5, and 6. We shall obtain the same answer using your permutation formula. 3 permutation 2. It's n factorial divided by n minus k factorial. Okay, k is equal to 2. I'm sorry, this one should be 2. Okay, I'm sorry. This one should be 2. And so it's going to be 3 factorial divided by 3 minus 2 factorial, which is equal to 1 factorial. And so again, it's equal to 6 divided by 1, which is equal to 6. Okay, so this is where I wish to introduce combination. Okay, look at this, A, B, and BA. Under permutation, you count this as 2 elements or 2 listing, 2 ordered listing. But not so with combination. With combination, these 2 elements, A, B, and BA, you count it as 1. So the same with AC and CA. Under permutation, these pairs are distinct. They are different pairs. But under combination, they are the same pair. Okay? So with permutation, we pay attention to the ordered listing of the objects, but not so with combination. Combination pays attention to the listing of elements without regard to order. So combination refers to the listing of elements without regard to the order by which elements are listed. Under combination, AB is the same as BA. Both are counted as one combination. But these two, they are counted as two pairs under permutation. How many combinations of R objects can you produce from a set containing n elements? It's equal to this. So you read this as n combination R. It's equal to n factorial divided by n minus R factorial times R factorial. And it is equal to this, n permutation R divided by R factorial. Okay, so this one, n permutation R, that is this, n factorial divided by n minus R factorial. These are the other notations for the combination formula. N taken R, that is how you read this, n taken R or n combination R. N taken R is the number of combinations that can be formed from n different objects taken R objects at a time. And this is how you compute it. Let S be equal to this. A, or the set containing A, B, C, and D. How many combinations can you form from the elements of S taken two objects at a time? List those combinations. So 4 taken 2. 4 elements. We shall take 2. And how many combinations of 2 elements can we form from this set? It's equal to this. 4 factorial divided by 4 minus 2 factorial times 2. Okay? And 4 factorial is this. 4 times 3 times 2 times 1. But 2 times 1 is just 2 factorial. 4 minus 2 factorial is 2 factorial. 2 factorial divided by 2 factorial is 1. And so 4 times 3 is 12 divided by 2. 2 factorial is just 2 times 1. So that is 2. So this one is equal to 6. And let us list those combinations. Those combinations are AB, AC, AD, BC, BD, and CD. 1, 2, 3, 4, 5, and 6.